time to have a look at some of the things that are happening in the world of science. We do that with Professor John O'Connor from the University of Newcastle, who this morning, no cup of coffee for you, John. So the fact that there's a lot of extra coffee waste around, you're not contributing to that this morning. Hello?
Good morning, Mark. I've had my coffee for the morning, yes.
All right. Now, it is one of those things that does produce a lot of waste, particularly when you add it up over the amount of cups of coffee that are happening across the country.
Just look at Australia, the number of people having coffee and the number of cups of coffee they have, and all up, it amounts to about 10 million tonnes of coffee waste, the grounds.
All got to go somewhere.
Well, most of it ends up in landfill, and that's the problem, because if it goes into landfill, then it becomes an environmental problem, because as it breaks down, it produces methane and carbon dioxide. It could go through, certainly in Lake Macquarie, they can put it through the food waste, but a lot of it doesn't go there. So it goes in landfill, it becomes a problem. But a group at RMIT have come up with a solution which actually solves another problem. The other problem is that is the booming construction market globally.
Yeah, there's always plenty of buildings going up roadways.
Lots of concrete, and that concrete requires sand and so forth. And in many parts of the world, extracting that sand has immediate problems and long-term environmental problems as well. So this group have actually come up with a way of actually solving two problems at once. Or at least ameliorating.
I wonder if they're getting paid double from there. No, probably not.
I don't know, get paid from two different industries. Yep, sounds like
that's the way to go.
Way. So what they do is they take the coffee grounds. You can't just put coffee grounds in place of sand in concrete, because it's got chemicals in it which would become toxic. They break down the metal, they'd corrode metal and so forth, the reinforcement. So that's not the solution. What they've found is that if you take the coffee grounds and you heat them up in vacuum, keep the air away, to a temperature of about 350 degrees C, it becomes biochar. Now, this is not the only material people have made biochar from. And in fact, I can go on a bit more about other materials in a moment, but they make biochar out of this. And then they add it to the concrete in place of sand, and they find it actually makes a stronger concrete. It's 30% stronger than if they'd used sand, which a double win, a triple win. I think we're almost up to triple wins.
Almost, here. Yeah, and it seems a very odd thing, doesn't it? Because you think, well, coffee as a substance, surely it's not as strong as sand. But again, you go through this biochar process, which sounds like something you'd find in a coffee shop. By the way, I'll have some biochar with my cappuccino.
No, I don't think they'll do it there. But anyway, yeah. But yes, the trick is to do it under vacuum. If you do it in air, then it'll oxidise and won't produce this stuff. But they've actually created biochar out of things like what's left over when they harvest wheat or other products. And when you put it in vacuum and heat it up to high temperatures, it breaks down. It often gives off gases, which then can be used to be burnt and run turbines and so forth. So that's been a very positive process. In certain parts of Australia, they actually use this to generate electricity, and that's a good green way of doing it, because it's come from the field. You burn it. Plant the crops next year, and so the carbon goes back into that. So it becomes a very renewable way. But in the case of this coffee, the coffee, it's a concentrated product. It's basically around the cities. It's already there to be collected, and so they've found this very positive thing. They've identified what's the best condition to do it on. They found don't heat it up to 500 degrees. A bit like the gremlins, don't feed them after midnight. But so they've now got to assess the long-term durability. Okay, it's now 30% stronger. Does it remain 30% stronger? Does it work well under freeze-thaw cycles, water absorption, abrasions, and all the other sorts of stresses that concrete will experience? But if it does, it means you've fixed one problem, and out of the process you've fixed another. And then once they've done all of that, they can go on to look at other forms of biochar from timber, from food waste and agricultural waste, see that they can be used to again be used into construction industry. Already biochar is used in the agriculture area by feeding it back into the soil. And if you do that, it increases the uptake of carbon in the soil, basically buries the carbon. It sits there for a very long time. It's a way of reducing the carbon in the atmosphere because it comes out into a crop, from the crop to biochar into the ground.
It is amazing, though, John, isn't it? The amount of things that can be used for something else. Well, somebody has to discover the pathway to it, but, we see this time and time again.
It's called the circular economy, and the ideal economy would be one where it truly is circular. You don't have to keep extracting things from the environment. You can actually keep cycling things through. And, of course, that's what the environment does for itself. If you look at all the stuff, anything that's a waste from one plant or animal, whatever, becomes feed for another plant or animal. And so that circular economy exists out there. We've just got to try and reproduce it.
I still love that term biochar, John.
You're going to try and work it into your conversation,
we'll figure it out. Yes, we'll figure it out somewhere, mate. As always, a pleasure. Thanks for your time.
Thanks, Mark.
Professor of Science from the University of Newcastle. There he is, John O'Connor, talking coffee and biochar at 2NURFM 103.7.
A broadcast service of the University of Newcastle.